Welcome viewers to another episode on ASUG 12 exams. So in this episode we are looking at the 2021 GCE Science paper 1, and this paper carries 85 marks and it's basically physics. So basically, without wasting much of your time, I'm going to move straight to section A. So section A carries 20 marks and it leads answer all the questions in this section. Choose the best answer from the letters A, B, C, or D, and then mark the letter with a cross X. So let us look at question 1. So A1 reads, the following dimensions of a metal sheet were measured by a welder using different instruments. Which instruments were used to accurately measure the dimensions? So we have thickness, which is 40 centimeter, then width 8 centimeter, then we have thickness 0.05 millimeter. So to measure length, what can we use? So we have a 40 centimeter. So if you look at the options, we have length, meter lu. For A is collect, B meter lu, collect, because it's a medium distance. Micrometer screw gauge, no, it's too small, it can't measure 40 centimeter. So C is out. D is still there, so we take out C. C is not an answer, out. We go to thickness. So thickness, we have basically A, micrometer, which is okay, because for micrometer screw gauge, the degree of accuracy basically is 0.001 millimeter, up to there, somewhere there. Then we have vernier caliper. So vernier caliper, on average, the degree of accuracy goes up to about 0.1 to 0.01 millimeter. So okay, so you can use a micrometer, but the micrometer screw gauge is more accurate for this small distance because of the small high degree of accuracy. So we have either a vernier caliper or micrometer. So meter lu is out. Vernier calipers can still be used, but we don't really use this. We really use this in physics. So I can take out D. So remaining with A and B. Then we go to width. So width is 8 centimeter, which is almost the same as the length of 4 centimeters. So if you use the length for meter lu, then with this we should also use a meter lu, and thickness micrometer screw gauge. So basically A is the correct answer. Remember, the degree of accuracy for a meter lu is basically 1 millimeter. That's it for meter lu. Okay, let us move to number 2. The following diagram shows a simple pendulum. What physical quantity can affect the period of a pendulum? So a period of the pendulum is basically the time it takes, the bulb takes to move from one position to go the other side and come back. So it's the time it takes to complete one oscillation. So what are the factors that affect the period? So number 1, we have the length of the pendulum. Length, which is length of the pendulum itself. Number 1, these are the factors that affect. So pendulum is basically the length, we are talking about this distance. So number 2 is basically acceleration due to gravity. So acceleration due to basically gravity. So how do these affect? So the higher the acceleration due to gravity, the shorter the period to take for the oscillation for the pendulum to complete one oscillation, because there will be so much force downward. Then the length of the pendulum, the longer it is, the longer it will take for the pendulum to move from the higher position to the other side and come back. Then what is key to note is the mass of the bulb. The mass of the bulb does not affect the period of the pendulum. It doesn't affect the period of the pendulum. Let us look at the options. So we have A, the mass of the bulb. So the mass of the bulb is a red flag. It doesn't, out. The length of the pendulum and acceleration due to gravity. So this is correct. Then the mass of the bulb is out, incorrect. Then the number of oscillation, because the number of oscillation is not part of the factors that affect the period of the pendulum. So basically B is the correct answer. We move to question number 3. So question number 3 reads, a student weighed a small amount of sugar crystals and found the mass to be 0.568 grams. After adding two sugar crystals, the mass was found to be 0.571 grams. Assume that the sugar crystals were identical. What was the average mass of one crystal? Okay, so for us to find the average mass of, we need to basically, so the average mass is given by basically the change in the mass after adding crystals, then divided by how many crystals? There are 2. Okay, so let us find the change in M. So the change in M, which is change in M, is given by M2, the new M minus the previous M. So M2 is basically the new one, which is 0.571, then minus 0.568 grams. We end up with 0.003 grams as the change. Then after that, we are able to find then average mass of these crystals will be basically 0.003 divided by T, which is basically 0.0015 grams. Now if you see the answers, from the answers that we have from options, we look at option A, B, C, D, you notice that these are in standard form. So let us write this in standard form. We move this decimal place how many times? 1, 2, 3. So hence this number becomes 10. Okay, it becomes 1.5 multiplied by 10 to the power negative 3, because it's moving from left. We are shifting the decimal place from left to right. So hence, if you check out the answers, you will notice that A is the best option. Let us move to question number 4. The following graph shows how distance varies with time for a cyclist ride that lasted for 250 seconds. What is the cyclist average speed for the whole journey? So average speed, so speed is given by total distance divided by time. So total distance divided by time. So what is the total distance? So this is distance. So what's the maximum distance? This is at 300. So this is 300. So total distance covered is 300. Then divided by what's the time taken? Is 250 seconds. 250 seconds. So at this point, just divide. So this one, that one. So what we have is 5 into 25 is a 5. 5 into 30 is 6. 5 into 6 is 1. Remainder 1. 5 into 2 is 2. So we have 1.2 meters per second as the average speed. So you notice that B is the correct answer. Let's move to question number 5. The diagram shows a car going around a bend at a constant speed. Which statement about the car is basically correct? So there is no resultant force acting on the car. So A is incorrect, because as long as the car is basically moving along a circular motion, there is a force which is pulling the car towards the center, and there is also a force that is pulling the center towards the car. So we have basically a centripetal force, which is the force that is pulling the car towards the center, which is this is the centripetal force. Then the pull of the center towards basically the car is basically the centrifugal force. So now, depending on whether these two are equal or not, then the car would be displaced. So there is basically a force acting on the car. Then the car is not accelerating. So as long as the car is moving in the circular motion and is changing the direction, there is acceleration because the gravity is changing. So B is incorrect. A and B are incorrect. Then a force of constant size acts on the car towards the center of the curve, and this is basically correct. And this is the centripetal force, which is perpendicular to the motion of the car. So C is what is correct. So basically, without even wasting my time looking at D, we can just move to D is incorrect. A force of constant size acts on the car in the direction of the motion. It's not in the direction of the motion. So in this direction of the motion, what is there is basically a path of inertia. Path of inertia. So it's resistance to maintain the same direction. So basically, that's how you answer question 5. Let us move to question number 6. In a small hydroelectric power station, 20 kg of water flows through a vertical height of 15 meters in 1 second. If so, we have the height, then we have the weight, then we have the time. If the efficiency of the power station is 60% and taking gravity as 10 Newton per kg, what is the power output of the hydroelectric power station? So we need to find, first of all, we need to find power. So what we know is, what is power? So power is the rate of doing work. So it's work divided by time. Work divided by time. So we know what time is. It's 1 second. But what is work? So the work is basically, we need to find work using work is equal to force times distance. Then what is force? So force is given by, in this case, mass times gravity. So let us find work done. Once we find work done, then it's easier for us to find the power. So, and we also need to remember that this power station is 60% efficient. So whatever work done, we are going to find only 60% will be the useful output. So we need to have now work done is equal to mass times gravity. When you replace F with this, then times distance. In this case, it's a vertical height, which is that way. So we are going to have basically what's the mass is 20 kg, then multiplied by what's the gravity is 10 Newton per kg. So 10 times the height is 15 meter. So once we multiply this, we are going to end up with basically a 3000 joules as work done, or joules as work done, 3000. Now out of this 3000, only this 60% is basically result into the useful output. So we need to know now the actual work done is equal to 0.6, which is 60% multiplied by 3000. We are ending up with 1800 joules. Then therefore we can use now the power formula, this power formula. So now power will equal to, now what is work done? The actual work done is 1800 joules divided by time. What's the time? 1 second. So we end up with basically a 1800 watts as the work, the power of this hydroelectric station. So basically that. Remember not to forget 60%. If you forget 60%, you are going to end up with C as the correct answer, which is incorrect actually. So B is the correct answer. Let us move on. Let us look at question number 7. The following diagram shows 4 identical metal cans E, F, G, H, whose outside surfaces were painted as indicated. Equal volumes of water at a temperature of 80 degrees Celsius were placed in cans. After 5 minutes in a cool room, which metal can would contain the coolest water? So the first thing that we need to understand is G and H, they have got lids. So the lids are meant to trap the heat inside or prevent the what is inside to become cold or to become hot. So G and H, of course, these are out. They can't basically let water cool down quicker than the other one. So now we remain with E and F. So to answer E and F, the principle that we need to use is the two key facts about colors. So in terms of emitting energy, heat energy. So what we know is black or dull colors or surfaces are good emitters of heat. So they release heat faster than shine or white surfaces. Okay, so since this is about losing heat, now what you notice here is the F. Okay, the F will release heat at a lesser rate compared to E. So E, because it's open, it will be faster than E. G, then and also faster than F, which is open, because F has a white surface, which is a poor emitter of heat. So basically A is the correct answer. One thing that you need also to remember is basically black or dull surfaces are also good absorbers of heat compared to white or shiny surfaces. You need to bear that in mind, because one or another you might come across that question. Let us move to question number 8. A crest of water wave travels 0.4 meters in 5 seconds. If the distance between two successive crests is 0.005 meter, what is the frequency of the wave? Alright, so what you need to remember is basically velocity of a wave is given by frequency times wavelength. So now we are told that between two successive crests, which is basically the wavelength, we have a distance of 0.005 meters. Okay, then so we know the wavelength. So the question is basically asking us to find the frequency. How can we find the frequency? Is to divide by wavelength both sides. So what we know is from here we end up with, by dividing this side we divide by that, and this side by that, we end up with frequency is equal to velocity over wavelength. So wavelength, we've already figured it out what it is. We need to find now velocity. So velocity is basically the speed. So we know that for 4 meters we cover it in 5 seconds. So basically speed is equal to basically distance over time. So velocity is the same as speed, but the fact that it has in a direction. So the meters is basically 0.4 meters, then we divide by time, which is 5 seconds, then we end up with 0.08 meters per second. Then we can easily now find frequency. So let me just demarcate here. So frequency is basically now equal to, what's the velocity? 0.08 meters per second divided by basically the wavelength, which is 0.005. This, if we multiply the numerator and the denominator by 1000, we end up with 80 over 5. 5 into 80 is basically 16. So we end up with 16 Ns. So if you want, you can just use the calculator direct from here. From here direct, you'll be able to get 16. So you go and look for the answers. So you know that D is the correct answer. We move to question number 9. An echo sounder in an aeroplane receives an echo from the ground 20 seconds after it was sent. If the speed of the sound in air is 330 meters per second, how high is the plane above the ground? Okay, so what is happening in this case, basically we're asking us to find the height. So what we have is basically, maybe this is a mountain, then the plane is somewhere here, then it sends the sound. So it's sending the sound, then it bounces back to here. So we have two equal distance being traveled. So it's going back and coming back. So we know that the speed is given by distance over time. So what's the time? The time is 20 seconds. What is the speed? The speed is 330 meters per second. But this sound is covering twice the distance. It's going back and coming back. So hence the distance need to be multiplied by 2. So now we end up with basically S is equal to 2d over time. So what is the speed? The speed is basically 330. So 330 is equal to 2d over time. What's the time? 20 seconds. 20 seconds. So just be careful that this time is the same comparable units with the speed. So speed is meters per second, so time should be in seconds. So if time was in minutes, we convert it into seconds, or the other way around. Then what this tells us is basically 330 multiplied by 20 is equal to 2d. We divide by 2, we divide by 2. So we know that 2 into 2 is a 1, 2 into 20 is a 10. 10 times 330, we end up with basically 3,300 meters as distance. So distance is 3,300 meters. Let us move to question number 10. The following diagram shows the formation of image I from object O using a convex lens, not drawn to scale. What is the focal length of this lens? So when you're talking about the focal length, what is basically a focal length? So once you understand what the focal length is, then it's very important. So the first thing that we need to know is we need to know what is basically the optical center. So the optical center is basically the center of this lens, which is this point. Then we need to also know what is a focal point is. So the focal point is whereby the ray that passes through the center of the lens and the ray of light, they meet. So it's this line, the center, the line passing through the center, and the ray of light meet. So this is the focal point. So now the focal length is basically the distance between the optical center and the focal point. So it's basically this distance. This distance is the focal length. So you notice from here is basically the correct answer. So the correct answer is basically 23 centimeter. Okay, let us move to question number 11. So number 11 reads, where is the image in the long-sighted ear formed, and how can the defect be collected? How can the defect basically be collected? So now we need to understand the two cases for the long-sighted and the short-sighted, because you can meet either of this question. So if you understand these two, the differences, then it will be much more easier for you. So for a long-sighted person, in this case, with a long-sighted person, what happens is this: the person basically can see distant objects clearly, but close distance or close objects appear to be out of focus. So long distance can be seen properly. Objects sitting on the long distance can be seen properly, but the ones that are short, they appear to be out of focus. That's for a long-sighted case. Then the short-sighted case is opposite. So distant objects are now out of focus, but short distance can be seen properly, easily for short-sighted. So what would cause short-sighted? So basically what you will notice that for short-sighted case is a case whereby the ear bone is too long. For long-sighted, it can be too short. Then for short-sighted can also be caused by the case whereby the ear ends are too powerful. Then for long-sighted is when they are weak. Okay, so let us look at how is the image formed. So for long-sighted, the image is formed behind the retina. For long-sighted, behind the retina. That's the first thing that you need to know. So long-sighted is basically behind the retina. Then short-sighted is basically in front. So in front of retina. That's what happens. So let us look at the option. So behind the retina basically is collect, but focused by means of concave. So concave is not focusing, it's actually diverging it, making it to form far away from the retina, to behind. In front is not in front. In front is for short-sighted, then in front is short. So we have basically bend the retina and focus by the means of convex lens. So we want to bring it normal to converge faster than later. So C is the collect. So for short-sighted, D would be collect short-sighted. So bear that in mind in case you meet a question like that. Let us move to question number 12. The following diagram shows the pattern and direction of the magnetic field between two magnetic poles J and K. Which type of poles are J and K? Now remember, the magnetic field moves out from the north pole, then enters the south pole. That's what you need to bear in mind. If this is north, this is south, the magnetic field moves like that. Then it enters like that, so it goes in this direction. It goes, so you need to look for those arrows. That's what is important. That's what is where the catch is. So if you notice from J, the magnetic field is entering, so that should be south pole. Then K, the magnetic field is coming out, that should be a north pole. So K should be north pole and J south pole. So you notice that the best option here is C. C is the best option. Okay, let us move to question number 13. So if you look at question number 13, number 13 leads two spheres. Basically, we have two spheres mounted separately on insulating stands. So this is to ensure that there is no share of charges. If both spheres are positively charged, which diagram shows a correct electric field pattern. So if they are all positively charged, remember the positive charge, the charge moves from out, inside to out. Then from the law of electrostatic, like charges, they repel each other. So we need to look for where the charges are coming out and they are repelling each other. So if you look at A, they are not correct because of course they are coming out and entering at the same time. So A is not correct. Then B instead of coming out, they are entering. So B is out. C, so C, if you look at it, they are all coming out. Okay, none of this is entering and they are repelling each other. This is correct. If you look at D, one is going in, the other one is coming out. So D is actually incorrect. So that's how C becomes correct. Let's look at question 14. The diagram shows a resistor connected to a cell of EMF 2 volt. How much heat energy is produced in the resistor in 6 seconds? In 6 seconds. So we are looking for energy. So we know what energy is. So energy is basically given by basically power times time in seconds. So energy, heat energy is given by power in. Now this power is measured in what? Then multiplied by time in seconds. Okay. So how do we find power? So power is given by basically voltage times current. So what is the voltage? The voltage we are given is 2 volts. What is current? Current we are not given, but we know that voltage is given by current times the resistor. So from this we can find current by dividing by R both sides. So meaning current is equal to basically voltage divided by resistor. So what is the voltage is 2. Then what is the resistor is 5 ohms. So 5. Then when we divide that, we end up with 0.4 amps as a current. Then after finding current, we can produce to find power. which will be just basically 2 volts multiplied by 0.4. This will give us basically 0.8 watts as the power. Now, having find power, we can find energy. How can we find energy? Let me use the heat energy. Red color now. Power is basically 0.8 watts, then multiply by time. What's the time? 6 seconds. Multiply that, we end up with basically 4.8 joules as basically the heat energy released. So hence, we check from the answer, we notice that C is the correct answer. Let us move to question number 15. So number 15, a 2 kilowatt stove, is a 0.2 kilowatt television set, and a 0.1 kilowatt lamp are all switched on at the same time. What is the total cost of running these appliances for 4 hours at 2 kwacha per unit? So now power is measured in kilowatt hour. So kilowatt hour is the unit. So what we need to do is we need to find basically the unit used in kilowatt hour. So let us say the unit used is basically, we call it UU, unit used, UU, which shall be X. So basically X will be equal to, basically we need to find the total power consumption. So we have 2 kilowatt plus a 0.2, which is a TV set, then plus a 0.1, which is a lamp. So now this is used by how many hours? 4 hours. So we end up with that. This is 2.3 multiplied by 4. We are ending up with basically 9.2. So 9.2 kilowatt hour used. Then per kilowatt hour, we are paying 2 kwacha per unit. 2 kwacha per unit. So to find the cost, so the cost is equal to basically unit used X plus, not plus, multiply. We are multiplying by per unit cost. So per unit cost. So what unit used, unit used multiplied by cost per unit. Okay, cost per unit. So we have unit used 9.2 multiplied by 2 kwacha, we end up with 18.4 basically 4 kwacha, which is basically D. Let us move to question 16. So question 16, a small coil is connected to a galvanometer as shown. What happens to the pointer of the meter when the magnet is pushed into a coil? The pointer, what does the pointer do? So the first thing is what happens when you move the magnet in the solenoid or this coil. So what will happen is, we know that from this magnet, the magnetic field is moving in this direction. Okay? Coming out from north towards the small coil. Now, if we look at basically Lenz's law of magnetic field, what it tells us is while we are pushing this magnet inside, okay, there will be an opposing current in such a way that there will be an opposing magnetic field that will be created. So the opposing will be coming out now. Let me use the red one so that you see the difference. So there will be the one coming in, then to create an opposing magnetic field like that. So what it means, this becomes the north. That's when we are going to have repulsion. Otherwise, if you south, there will be attraction. Then this becomes the south. So because of that, there will be a current moving in an opposite direction to them. This coming in electric charge. So what you notice here, we have this current moving in this direction. Hence, this galvanometer would deflect to the basically right. So it would deflect to the right direction. So let us look at the answer. So it will only deflect when the magnet is moving Once the magnet stops moving, it returns to 0. So deflect to the left and then returns to 0. No, it can only do that if you are pulling away. That's when to go to the left, or you are putting the south pole. Then deflects to the right and then returns to 0. So this is the correct answer, which is B. Okay, so C and D, they are not correct at all. It's not continuous reading, it's just momentarily as you are moving. Let's move to question number 17. Which graph shows the voltage output V against time for an AC generator? So an AC generator is as alternating current, so meaning the voltage alternate between positive and the negative. So what you will notice here is there is only one correct answer which shows the alternating voltage against time is D. So D is the correct answer for AC generator. A would be for a DC generator. B and C, they are totally incorrect. So one thing that you need to bear in mind is basically when you are generating this power for AC generator, they normally use basically slip links. Then for a DC generator, they use split commutators. So this is slip links, then this is split commutators, which makes it possible for them to maintain just a positive charge as shown in A. Let us look at question 18. The following diagram shows the appearance on the screen of alternating voltage applied to the input of an oscilloscope. The sensitivity is set to 3 volts per centimeter. What is the maximum voltage? Okay, so this is clear. So we are starting from here. So we know that for every 1 centimeter is equivalent to 3 volts. Then how many centimeters are here? So we need to count 1, 2, 3, 4. So 4 centimeters is equal to what? So it's what we're looking for, x. So x times we cross multiply here. So we have x is equal to basically 4 times 3 volts. We end up with basically 12 volts. 12 volts is basically the correct answer. Let us move to question number 19. Radioactive iodine is used to treat tumors of the thyroid gland. It decays by emitting beta particles and gamma radiations. The beta decays processes is represented by the following equation. What is the nucleon number A and the proton number Z for the nucleus of Xe? So quickly we have 131, then 53, then this is E, element. So if this element basically what it does, if it's undergo basically a beta decay, okay, a beta decay, so what happens is it will basically lose 1 electron. So we have basically the nucleon number will not change, it remains 131. Then is the proton number which will basically increase because it's gaining. So this one becomes 54, then plus basically that electron that it has gained, so plus energy. So what you notice here is, so the value, the nucleon number remains at 131, then the proton number becomes 54. So you see from here is that C is the correct answer. Let's move to question 20. A radioactive isotope has a half-life of 6,000. How much time passes before the rate of emission from a sample of these isotopes falls to 1/16 of the original value? So we know that half-life, which is at a particular time, the value of half-life is equal to the original value multiplied by half to the power t over h, where h is the half-life. So we know that the half-life here is 6000. Then what it means at a particular time t is 1/16. So a is what it means at that particular time. So it's 1/16 is equal to basically a, or it's basically the 1, because it started with the entire thing, so it's just a 1. So 1 multiplied by half to the power t, we are looking for t over h. What is h? 6000 years. Then from here, the key thing that we need to know is 1/16 can be written as 1/2 to the power of 4. This can be, because what we mean is half times 4 is 1/4 times half is 1/8 times half, 1/16. So hence now we can replace this one to be 1/2 to the power 4 is equal to 1 times anything is that thing, half to the power t over 6000. So because the law of indices, these bases are the same, it means the powers should be basically the same. So we have hence basically just to demarcate here is 4 is equal to t over 6000. Then you can solve for t by cross multiplying. So basically 4 multiplied by 6000 is equal to t. So 4 times 6000 is equal to 24,000. So hence t is equal to basically 24,000. So we come and check from the answers, we found it to be C. So basically this is how you answer these multiple choice questions to get the optimal 20 marks, which is very important towards you getting that distinction. So thank you. Join me as I look at section B and C of this paper.